Concrete beam of rectangular section only, correct? Mm, okay, by 250 is the cross section given in the problem, correct? Cross section 125 by 250. Okay, let me write the centroidal axis. Centroidal axis. Centroidal axis. Now, the pre-stressing force is given 220 kilonewton. Then coming to the cable profile, just go through it. The central line of the cable is parallel to the axis of the beam, and 75 above the soffit over middle third portion of the beam. Okay, middle third portion of the beam. Axis is parallel to the cable is parallel to the axis of the beam. I'll divide this whole figure into 3 parts. Okay. So for middle third portion, the axis of the cable is parallel to the centroidal axis. Okay. The central line of the cable is parallel to the axis of the beam and 75 mm above the soffit over middle third of the span. Okay, and it is a straight cable. Okay, for middle third portion of the beam, and it is at a distance of 75 above the soffit of the beam. Okay. Next, moving ahead, and curved upward in a parabola, over the outer third of the beam to a distance of 175 above the soffit at the support. Okay, so total depth of the beam is 250 So 250 divided by 2 is 125 you will get, means distance of centroidal axis from the soffit of the beam. He says that the it is curved upward in a parabola over the outer third of the span to a distance of 175 above the soffit at the support. Okay, 175 means, so here from the soffit if you measure 175 so it will go above the centroidal axis. Okay, centroidal axis is at a distance of 125 so here up to here it will go. Okay, so he says that it is curved upward in a parabola. Okay, like this, it is curved upward in a parabola like this. Curved upward in a parabola like this, up from here to here, 1/3 is straight, and remaining 1/3 on edges are parabola. That is the meaning. Okay, so here up to here it is 125 mm. Okay, so here eccentricity 1 above the central axis, you will get it as 50 mm. Correct? Total is 175. Total is 175. So 175 minus 125, if you calculate, you will get 50 mm as E1. Similarly, here E2. E2 will be equal to how much? So 125 minus 75. So we'll get 50 mm as E2. 50 mm as E2. Okay. I hope you all understanding. Okay. E2 is 50 mm and E1 is 50 mm. Okay. If the modulus of elasticity of the concrete is 35 kN per mm square and the density of the concrete is 24 kN per meter cube, calculate the upper deflection due to prestress only, deflection due to prestress plus sulfate. Then magnitude of the concentrated loads placed at 1/3 points of the span, which would result in limiting short-term deflection of span by 500. We will go solving one by one. Okay. What is the first question? Upper deflection due to prestress only. Upper deflection due to prestress only. Okay. The second question is deflection due to prestress and the sulfate. Okay. What you do is first you calculate the deflection due to sulfate, then you calculate deflection due to prestress. You can find the answer for both. Correct. What about the length of the beam? Length of the beam is given as 8 meter. Let me mention here. Length of the beam is 8 meter, nothing but 8000 mm. Okay. 8000 mm. Length of the beam is 8000 mm. Okay, we will resume the class. So we'll calculate one by one. First, we will calculate deflection due to dead load. First one, deflection due to dead load. Deflection due to dead load. Delta DL. Same procedure. First, you calculate the sulfate at dead load. Dead load of beam is equal to cross sectional area multiplied by density. Okay, cross section area is 0.125 into 0.25 into 24 is the density given. So you get Wg as 0.75 kilonewton per meter. 0.75 kilonewton per meter. Okay, so we know the formula for calculating deflection due to dead load, that is 5 by 384 Wg L raised to 4 by Ec into Ix. So Ix you can calculate is equal to BdQ by 12. BdQ by 12. B is 0.125 and depth is 0.25. 125, and in terms of mm raised to 4 we want now. So 125 into 250 cube by 12. So you'll get the answer as 162.76 into 10 power 6 Newton millimeter. Okay. Therefore, DL is equal to 5 by 384 into Wg is in terms of Newton per millimeter, it is 0.75 only. Newton per millimeter. So 0.75 into length of the beam is 8,000 raised to 4 divided by EC. EC, it is given in the problem 35 kilonewton per mm square. Okay, EC is given as mm square. In terms of Newton per mm square, it is 35 into 10 power 3 Newton per mm square. So 35 into 10 power 3 into Ix 162.76 into 10 power 6. Okay, so we'll get the answer as 7.02 mm. 7.02 mm. Positive sign indicates the deflection is in downward direction. Similarly, you find deflection due to prestress. Deflection due to prestress. Question B. Question B. Deflection due to prestress. Delta PS. Deflection due to prestress. Okay. Now here we have different profile of the cable. Okay. Here some part of the cable is above the central axis and some part is below the central axis. Okay. If you write the bending moment diagram, okay. So for the cable which is above the central axis, this is what the PMD. The sign is positive. Okay, because cable is above the central axis. Then for cable which is below the central axis, the type of VMD is similar to the cable profile only. Similar to the cable profile only. Okay. This is what the nature of bending moment diagram. So this is rectangular portion and here parabolic portion. Okay. So whatever the cable profile is there, same kind of VMD you will get it for BMD profile. Okay. Now here P into E as usual. P into E. P into E. Okay. So here E1 P into E1 is equal to, so pre-stressing force is given. How much it is given? 220 kilonewton. It is given as, I think sir. Open ಮಾಡಿ sir ಬರ್ತೀನಿ. P is equal to 220 kilonewton. 220 kilonewton means 220 to 10 power 3 Newton. E1 is 50 mm. Correct? So if you calculate, you will get the answer as 11 into 10 power 6. Okay. So here P into E1 plus E2. P into E1 plus E2. E2. So P is 220 into 10 power 3. So E1 plus E2 is 50 plus 50. Correct? E1 is 50, E2 is also 50. 50 plus 50. So you get the answer as 22 into 10 power 6. Okay. 22 into 10 power 6. Okay. So here the sign is negative. Okay. Here the curved portion of the cable is below the central axis. That is why sign is negative. Here at the support, cable is above the central axis, so sign is positive. At the midspan, the cable is below the central axis, sign is negative. Sign is very important. Okay, be careful. Okay, negative. Okay, now you have to follow the same procedure. You have to use the same generalized formula, area into x bar divided by E into I. You please keep doing the problem. I will be back in another 2 minutes. Okay, please keep doing the calculation. We will resume the class. Now I will take half of the BMD. Write the center line here. Okay. Now here. So let me shade the half of the BMD. Okay. Now what we will do is we will divide this figure into two regular components. Two regular components. So this will take this parabola will this rectangle will take as component number 1. Okay. This parabola will take component number 2, and here one more rectangle we have, we will take this as component number 3. Component number 3. Okay. So the total length of the beam given is 8000 mm. So 8000 divided by 2, if you do, you will get as 4000 mm here. This will be 4000 mm. Okay. Then here, if you take the cable profile, here you can see one third. This is the cable is straight for middle third portion. Correct? This cable is straight for middle third portion. So here total length will be okay. So here if you divide this lengths into 3 parts, means 8000 divided by 3, you will get the answer as 8000 divided by 3. You get the answer as around 2666.6 mm. Correct? 2666 mm. So here it is 2666 mm, and this is also 2666 mm, and this is also 2666 mm. Okay. Now what we have done is we have taken this rectangle 3. Okay, this rectangle 3, width of this rectangle 3, if you calculate, it will be how much? 2666 divided by 2, means you will get it as 1333. We'll get the width of this rectangle 3 as 1333. Okay, 1333. Now height is known, 22 into 10 power 6. 22 into 10 power 6. Height is same. Okay, I hope this is clear for everyone. Now we can apply that generalized equation to calculate the deflection. Therefore, delta PS is equal to area into x bar divided by EC into IX. Okay, if we elaborate this formula with respect to this figure, it will be, see, the first component is having positive sign, so it is plus A1 x1 bar. Then second and third components are having negative sign, minus A2 x2 bar minus A3 x3 bar whole divided by EC into IX. Okay, now you find all the areas, all x1 bar, x2 bar, and x3 bar. Let me mark the all centroidal distances here. Now distance of rectangle 1 is x1 bar, Okay, total is here. It is total length is 8000. 8000 divided by 2 is 4000. Okay, here for like rectangle 2, let me call it as G2, and so distance I will call it as x2 bar. Okay, similarly, I will call distance of centroid of rectangle 3 as G3, and its distance from nearest support as x3 bar. x3 bar. Okay. Now you can find all the areas. A1 is equal to area of component 1. Component 1 is of rectangle having width 4000 and height 11 into 10 power 6. So it is 4000 into 11 into 10 power 6. If you calculate, We'll get the answer as 4.4 into 10 power 10. Then x1 bar. Okay, x1 bar means distance of center of rectangle one from nearest support. It will be 4000 divided by 2, 2000 mm. 4000 divided by 2, 2000 mm. Then A2 is equal to area 2, area of this parabola 2. Okay, what is the formula for area parabola? It is 2/3 of base into height. 2/3 of base width of parabola is 2666. 2666 into its height is 22 into 10 power 6 into 22 into 10 power 6. Answer is 3.91 into 10 power 10. Then x2 bar. x2 bar. Okay. So x2 bar for parabola, distance of centroid is 5 by 8 of b. Therefore 5 by 8 of b is 2666. You will get it as 1666 mm. Okay. Then A3, area of rectangle 3. Area of rectangle 3. Its width is 1333 and height is 22 into 10 power 6. 1333 into 22 into 10 power 6. Okay. So it is 2.933 into 10 power 6. So 10 power 10. Okay. 2.933 into 10 power 10. Then coming to the x3 bar. x3 bar means distance of center of rectangle 3 from nearest support. Okay. You want x3 bar, correct? x3 bar means from here it is at a distance of 1333 divided by 2. Correct? b by 2. b by 2. Okay. So distance of center of rectangle 3, distance of G3 from nearest support is, it is how much? 2666 plus b by 2. 2666 plus 1333 divided by 2. Okay, I hope you are understanding. You need to calculate this distance from nearest support from here to here. Okay, so it is 2666 plus 1333 divided by 2. Okay, that is 2666 plus b by 2, which is nothing but 2666 plus 1333 divided by 2. You will get the answer as 3332.5 mm. Okay, now we can substitute all the values to get the deflection due to prestressing force. Therefore, delta PS is equal to A1 x1 bar. A1 is 4.4 into 10 power 10. 4.4 into 10 power 10. Then minus A2 x2 bar. Minus A2 is 3.91 into 10 power 10 into x2 bar 1666 minus A3 x3 bar minus 2.933 into 10 power 10 into x3 bar 3332.5 whole divided by EC into IX. EC is 35 into 10 power 3, IX is 162.76 into 10 power 6. 35 into 10 power 3 into 162.76 into 10 power 6. Therefore, delta PS is equal to, if you calculate, you will get the answer is minus 13.15 mm, which is in upward direction. Negative sign indicates deflection is in upward direction. Okay. Now coming to the question, the upward deflection due to prestress only. We already got this answer. Okay. Therefore, first question, upward deflection due to Pre-stress only. Pre-stress only is equal to delta PS is equal to minus 13.15 mm. Okay. Second question, coming to the second question. Deflection due to pre-stress plus self-weight. Second one. Deflection due to pre-stress and self-weight. And self-weight is equal to delta PS plus delta dead load. Delta PS is minus 13.15. Delta dead load, delta DL plus 7.02 plus 7.02. So you get the answer as minus 6.13 mm. Minus 6.13 mm. Negative sign indicates deflection is in upward direction. Okay. Next, coming to the third question. It is asked to find the magnitude of the concentrated loads placed at 1/3 points of the span, which would result in limiting short-term deflection of span by 500. Which would result in limiting deflection of span by 500. Okay. The concentrated loads placed at 1/3 points. How? Third question. So 1/3 points means here and here. L by 3, L by 3, and L by 3. Okay. We have to find magnitude of the concentrated force W, which is placed at 1/3 points, which would result in short-term deflection of span by 500. Which would result in short-term deflection of span by 500. Short-term deflection means what? Short-term deflection means short-term deflection. Okay, we have to find magnitude of the concentrated load W, which is placed at 1/3 points, which would result in the short-term deflection of about span by 500. Okay, span by 500. Span by 500. Short-term deflection is nothing but it is the sum of deflection due to dead load plus deflection due to live load plus deflection due to pre-stressing force is equal to span by 500. Okay. Deflection due to dead load is known. Deflection due to dead load is 7.02 mm plus 7.02 mm plus deflection due to live load we have not determined. Okay, we have not determined. So here what is the type of live load given in the problem in the third question? Concentrated load which are placed at middle third of the portion, 1/3 portion points. Correct. I'll go to the theory part here. Just look into the finding of deflection due to live load. Okay. Yes, here. Okay. So you can see. Okay. the loads are placed at middle third points. For that, deflection due to live load is calculated as using this formula 23 by 648 WLQ by EC into IX. Okay. This is how we calculate for deflection due to the point loads placed at 1/3 points. Okay, what is the formula? This is the formula 23 by 648 into WLQ by EC into IX. So the deflection due to live load here is, I'll copy the same formula here. It is 23 by 648, 23 by 648 into WLQ by EC into IX plus delta PS, deflection due to prestressing force. That is how much? Minus 13.15 mm. I'll change the sign here. Minus 13.15. Minus 13.15 is equal to span by 500. Span is 8 meter, nothing but 8,000 mm divided by 500. Now we can substitute to EC is known, IX is known, length is known, only W is the unknown factor. We can find it now, correct? Therefore, if you take this 7.02 and minus 13.15 to the RHS, you will get or else you will 23 by 648. I'll keep this central term as it is into W into L is 8,000 cube divided by EC into IX. EC is 35 into 10 power 3 into IX is 162.76 into 10 power 6. EC into IX is equal to, I will take this 7.02 and minus 13.15 to the RHS. Okay, after simplification in the RHS, you will get it as 22.13. Okay, now W is the unknown parameter. You can find it. If you find the answer, you will get the answer as 10.71 Newton. Okay, let me check the answer once. Here 8,000 divided by 500 will be 16. Okay, 16 minus 13.5 if you take to the RHS, it will be plus 13.15 and plus 0.7.02 if you take to the RHS, it will be minus 7.02. So it is 22.13. Okay, so 22.13 into 648 into 35 into exponential 3 into 162.76 into exponential 6 divided by 23, correct? 23 into 1000 cube, 8,000 cube. Answer is different, no? Yes. Let me change the answer then. It is 6937.04 Newton. W is equal to 6937.04 Newton. 6937.04 Newton. Okay, or 6.93 kilonewton. Okay, this is not the answer. So answer is 6.93 kilonewton. Let me recalculate it once again for confirmation. It is 22.13 into 648 into 35 into exponential 3 into 162.76 into exponential 6 divided by 23 into 8,000 cube. Yes, same 6937.04 Newton, 6.93 kilonewton. So in the notes written the different answer, please correct it, students, in the notes. In problem number 4. So at the last I written 10.71 Newton. Please correct it. Okay. Correct it to 6.93 kilonewton. Okay, to this problem is over. Any doubts you can ask in this problem? Okay, to this we'll end the class and we'll continue in the next class. Thank you.